How do debugging tools work with microcontrollers? Have you ever wondered how developers fix bugs in microcontroller programs? Debugging tools play a key role in this process. They create a connection between a computer and the microcontroller hardware. This link allows developers to see what is happening in real time, making it easier to identify and fix issues. At the heart of debugging are hardware interfaces like Joint Test Action Group and Serial Wire Debug. These connections let the debugger pause the program, step through code, and inspect memory and register values. This is essential for understanding how the program runs and where it might be going wrong. There are two main types of debugging tools used with microcontrollers. First, we have on-chip debuggers. These are built right into the microcontroller. They allow developers to access the processor's internal resources without needing extra hardware. This is especially useful for debugging code that interacts with hardware or requires precise timing. On-chip debugging is often more cost-effective and straightforward but may lack some advanced features. The second type is external debuggers, which include in-circuit debuggers and emulators. These tools connect to the microcontroller through the debugging interfaces we mentioned earlier. They provide more advanced features, such as instruction tracing and complex breakpoint management. For example, in-circuit debuggers allow developers to debug while the microcontroller runs in its actual circuit. This capability is vital for spotting subtle bugs that might not show up in simpler debugging environments. Debugging tools often work with software development environments, making it easier for developers to control their debugging sessions. They can visualize memory states and analyze how the program behaves. Popular tools like Seger JLink and Lauterbach trace 30 to support many microcontrollers and offer features like power consumption analysis. In addition to hardware tools, software-based simulators and traditional methods like code tracing also help in debugging. Developers can use oscilloscopes and logic analyzers to monitor electrical signals and timing in embedded systems. To effectively debug with microcontrollers, developers should know how to set breakpoints, step through code, inspect variables, and trace program execution. These skills help them identify unexpected behaviors and verify system states using hardware signals. By using these debugging tools wisely, developers can find the root causes of software bugs in embedded systems. This leads to more reliable microcontroller applications and smoother user experiences.